All right. So last week we did the first exam. At this point, I think there are still a couple of students who have not completed the first exam. Ethan, are you here?
Yeah, I was meaning to talk with you about that. I didn't read that you have to what was it, pre-register 2 days before. So I just did that. I think
Onboarding exam?
yeah.
Okay.
So I was just waiting till I think today is I can do it now, or
Okay. All right.
I'm not sure.
Okay.
Sorry about that though. That's my bad.
Right. Yeah. So next time when you take the exam too, you shouldn't have to take the onboarding exam anymore. You only have to do it
Okay.
one time. Okay. I can take a look at see if you are approved. Because it usually takes, sometimes it's quick, a few hours, but sometimes it may take a longer time. And Bryson, are you here? No? Okay, Bryson's not here. Okay. Uh, Again, the common problem I found is not the ID not legible. Probably just um, it's your ID. You have to hold ID close to the camera, otherwise the picture is not very clear. They cannot read the name on the ID. So that's another reason they reject you most of the times. Okay, let me see anybody else who hasn't completed the exam yet. So most of the students have already taken the exam. I am still in the process of grading. Some of the students might have seen your grades for first exam posted already. So again, this whole process takes a much longer time for me to grade, and I've finished grading 2 classes, but I still have 2 classes I have to um, complete the exam. So I will finish everything by the end of tomorrow. So if you don't see your grades for exam one yet, you should be able to see your grades by the end of tomorrow, Wednesday. Okay. And right now, I right now I saw that the highest so far the students I graded we have a highest score 96. Uh, Stephanie, is Stephanie here? No, she's not here. Okay. But I did see some students who didn't do very well, um, and if you would like to see what problems you missed, you can send me an email. I can email the grading to you which problems you missed. And notice that one of the major thing is factoring. And if you still don't know how to do factoring, you might need to get help or either come to my office hours or schedule time with me or find a tutor to help you. That's what we're gonna do today also. So maybe after today's class, you you will feel better about factoring.
Also,
E- Yeah, go ahead.
can I, the I don't know if it's just your class or not. Like I can turn stuff in every other class, but the practice exam I saw that was put in. But I just sent you the homework 5. It won't let me turn it in the.
See, I don't know. You might have to contact IT.
I don't know why it does that. Yeah, it's
Yeah, some students also have the same problem. I don't know why either, but most students seem to be okay, but some students did have trouble.
okay.
You are not the only one.
I emailed you about it a couple of days ago. I don't know if you saw that, but I just sent you the file now.
Yes, I think I emailed you back.
Oh, okay.
So what I usually tell everybody is, um, if you usually after, I think I did email you back. So usually after you submit it, you should receive an email immediately telling you it's like a confirmation of your submission.
So if we
Uh,
don't get that, just check again
right. If
and
you don't
make
get
sure.
it, it just means your submission is not successful. In that case, you can try it again or just email them to me.
Okay.
That would be easier for everybody. So that's what I have been telling everybody to do. So just send me an email and telling me you're having trouble submitting to Blackboard. So I'm not sure what caused that problem, but like I said, I do have probably every class I do have maybe like 4 or 5 students who have trouble. Well, I guess it depends. There's one class we only actually pretty much everybody was able to. I had online class with 40 students. It's purely online and no class meetings, and it seemed like nobody had trouble submitting. But I don't know why. Some in other classes, students had trouble submitting. And again, you might have to check ID, check with IT, the IT. I don't know why what caused the problem. I mean, in the past, sometimes it's because the picture file is too big, or it could be the internet connection speed. I don't know, so I'm not really sure what caused the problem. Again, just email the pictures to me. So always do that, and also make sure you check again. Make sure you check your emails because usually on the next day, so the due date is always Tuesday, most of the time, unless it's exam day. Uh, on Wednesday, I always check who has submitted, who has not. So I'll send an email reminder to everybody who has not submitted, and to let you know you missed the deadline. You need to email to me or submit it as soon as possible. So also check your email, if you receive that email, it means your submission didn't go through or something just happened. Just email to me your work or try to resubmit. Okay. All right. So that's something about a little bit about technology problems. And the I think when we take the second exam, the final, it should be easier for most of us since you already taken the first exam. Some of you didn't get the proctor track to work, and I used Microsoft Teams to proctor the exam for those students. You can do that as a backup solution. You just have to schedule time with me, and but I think for the second exam, third exam, I will make a little bit change for submitting your work. I can make it on Blackboard. So instead of you taking pictures, emailing to yourself, download it, submitting from your computer that way, and I would just make a place on Blackboard so you can just use your phone to submit to Blackboard that way. Okay, and also when you do that way, it's easier for me to grade, and also you will see what you can see the grading marks just like the homework. So right now, the files response that I have, most of you did. You can see your grading marks. I cannot grade there. I have to download every picture you send and um, grade on my computer and grade them on my computer, and you won't be able to see any grading marks, which ones you missed. But for the second exam and final, I will do that, so you will see what questions you missed. Okay, so that's something about the exam. And again, homework assignments, make sure you keep turning in your homework assignments. Again, that's a major part of your grades. So you don't really want to miss one or two assignments that can bring down your average a lot. All right, so today we're gonna continue. There, just a reminder, there's a homework assignment due today. Homework 6, and um, if you have any trouble doing any homework assignments, there are videos extra. So I have recorded class video on post on Blackboard. I also have some extra videos for each problem in your homework worksheet. There is a example similar to that you can follow to do the homework assignments. Okay. So let's look at this week. So last Thursday, we talked about the applications of factoring. So why do we learn to do factoring? One type of question is to solve. Let me share my PowerPoint slides with you. Okay. So one type of question we use factoring to do is like in your homework. So if you have x squared minus 2x plus 8 equals 0, and you want to solve for x, because these are not like terms. They cannot be combined into a single x term and then to get rid of number in front of x that way. So we had to do factoring. Um, I guess I think some students use the quadratic formula to do it. Um, Well, that's something we're going to talk about later in chapter 6. And I did say that in class, there is a different way to use quadratic formula. I wouldn't say it's wrong, but in this section, we would like you to solve the equation by factoring. So that because that's what we're learning the applications of factoring. Why? So what can factoring help us? What kind of problems factoring can help us solve? So that's what we ask you to do to follow the steps. So that's the first type of question. The second type of question is, let me go ahead and just show you the homework problems you had week 6. Week, let's see. Because today we are going to continue to look at applications of factoring. Okay, so like these questions. So you're supposed to solve them. I didn't say by factoring. If you did a quadratic formula, I wouldn't say it's wrong. I will still give you all the points, but we did want you to use factoring to do all these questions. And the other type of question we use factoring to do is to simplify a fraction. We don't call them fraction anymore. We call them rational expression because they're mixing numbers and variables. So in order to simplify these, you must factor the top and the bottom and then find the common factors to do that way. Okay, so that's what we discussed the last time. So today it's going to be very similar to section, the problems you did in 4.1. So let me switch back to the PPT. Okay, so this process is what we discussed last Thursday. So I compared the process of simplifying a rational expression to simplifying a fraction. Although this is totally different problem, the steps are exactly the same. So as you can see, really rational pretty much means fraction. The reason we don't call it fraction anymore is because we have variables. Usually when we say fraction, we only have numbers in the denominator and numerator. So in order to simplify a fraction, what we did before was to one of the possible solution is to factor the numerator and the denominator. So factor 18 as 2 times 3 times 3, and factor 10 as 2 times 5. And we found the common factor 2 and 2. We cross them out. And then to step 2, you cancel common factors, and then you multiply whatever left straight across. So 3 times 3 is 9, and bottom there's only one number, 5. So that's the steps we did before. I mean, there are other ways. The other way to do it is maybe you realize 2 goes into both of them without doing factoring. And this factoring can show what number can go into both top and bottom. But if you can see that, you just went ahead and divide both top and bottom by 2 this way. And instead of factoring, cross them out, that's also correct. But that way doesn't really work for rational expressions because when you get something this complicated without doing factoring, it's very hard or almost impossible for any of us to see what can go into the both top and bottom. See, after we do factoring, we are able to see 5x minus 4, 5x minus 4 goes into both top and bottom. And I don't think anybody can see 5x without doing the factoring. Just by looking at the top and the bottom, we can see 5x minus 4 goes in there. I mean, it's pretty much impossible. So that's why we must do factoring. Although for numbers, you are able to see, most of us should be able to see 2 goes into both 18 and 10, but none of us can see 5x minus 4 goes into both top and bottom here. Okay, so that process cannot be omitted. You must show the factoring. Okay, so the steps are exactly the same. So factor the top. Again, this is an example I did last Thursday, so you can go back to watch the video if you missed the class or if you want to watch it again. And you factor the top, bring out greatest common factor, GCF, and then you get a trinomial. You still have to factor the trinomial to get another 2 factors, and let's do the same thing for the bottom. And after you do the factoring, you can see 5x minus 4 as a common factor, and also x and x is a common factor. You can cross them out and multiply straight across. Negative times x, negative times 3. So that's it's exactly the same steps, but of course, simplifying rational expressions is much more complicated than simplifying numbers. The other important thing I want to mention is whenever you want step two, whenever we cancel the common, see, I've emphasized here factors. So whenever you cancel something from the top and the bottom, you must make sure it is a factor. And how do I know whether a number or expression is a factor? It has to be multiplication. Okay, so like 2 times 3 times 3. So it's all multiplication. That means 2 is a factor, 3 is a factor, 3 is a factor, 2 is a factor, 5 is a factor. If both 2 are factors, you can cross them out. So again, a mistake possibly, I mean, for numbers, nobody's going to make this mistake. But again, when we reduce 6 over 4, you will break down. When we say breakdown, we mean factor into a product. So 2 cancels 2, that gives 3 over 4. So look, it's multiplication between 2 and a 3, 2 and a 2. But if you try to break down as addition, that doesn't work. So you can get 2 plus 4 equals 6, and 2 plus 2 equals 4. And try to cancel out these two. That would be incorrect because we can never cancel out um, terms, because 2 is called a term because it's plus. So this is incorrect. So please don't ever do this. You can these twos can be canceled out because they are called factors. Okay, multiplication, that makes them factors. If it's plus, that's not a factor. That's called a term. You can never cancel terms. So go back to the very beginning. You are not going to be able to cancel this 5 and 10 or this x cubed, that's cubed, because there's a bunch of minus and plus behind it, which makes x cubed not a factor. X cubed, actually 5x cubed is a term. This whole thing is a term. So 5 is not a factor of the whole top. X cubed is not the factor of the whole top, which means you cannot cancel out this x cubed and this x cubed. So make sure you don't do that. Okay. All right. So now we are going to continue to look at today's topic. So if you remember during the first week, I reviewed all the if you look at your homework one, I think I can go back to show you. So everything we're doing in this section is very similar to what we did in during week one of when we reviewed operations of fractions. So I'm gonna go back to week one and bring up homework one that you did before. Okay, so homework one. So in homework one, the this question here, reduce 18 over 32. That's similar to the one we just did. So, but now we are learning to reduce a rational expression, which means in the top you have variables, in the bottom you have variables. But the process is similar to how you reduce 18 over 32. And then I also reviewed how to divide two fractions, how to multiply fractions, and then how to subtract or add fractions. So that's why why did we review this? Because we are going to do these again and with the variables in there. So these two questions, type of question, multiply and divide fractions, um, are going are going to be in the next the topic for today. I may not have time. I don't know if we're going to have time to talk about addition. Maybe a little time to talk about a few problems of addition, subtraction. But that's what we're going to do today. Okay, so let's go back to the slides. All right. So now today we're going to look at how to multiply fractions. Okay. So first, look at the second column here. First column tells you the steps to multiply fractions. So when we multiply fractions before, we multiply straight across. So the top 9 times top 10, bottom 35 times bottom 20 step. And the second step, we factor each of them. Again, there's a different way because for numbers, you are able to see, for example, 3 goes into 9, 3 goes into 21. You can go ahead and reduce that way. But I didn't want to do that way because for rational expressions, it's hard to see the what goes into both of them. So I just gonna break down 9 as 3 times 3, break down 10 as 2 times 5, break down 35, the bottom 35 as 5 times 7, and 21 as 3 times 7. And notice in the top and the bottom, the only operation I have is multiplication, multiplication. So you shouldn't have plus or minus anywhere. Okay, so each of the number can be called a factor now. If there are factors, we can cross out the common factors. So let's look for the common factors, 3 and a 3, and 5 and a 5, and that's it. There's no more common factors. So on the top, we have 3 times 2 left, and the bottom we have 7 times 7, and we just multiply whatever left. Oh, I'm sorry, it should be a 6 here. 3 times 2 is 6. 7 times 7, it's 49 here. Okay, so that's what we did reviewed during the first week, how to multiply fractions, those 4 steps. Now, how to multiply rational expressions? We have we do similar process. The first type of question, also it's the first one in your week 7 homework, the first problem on under week 7. And in this question, notice all the operations you see are multiplications. So between 4 and 8, nothing, which means multiplication. There's multiplication here, and 9 times A times B, 10 times B cubed, and B cubed is also means B times B times B. So it's all multiplication in here. If you already have everything in multiplication, you don't have to do factoring at all because each of them will be called a factor because you only have multiplication. There are many different ways to do this. What I'm going to show you here is a common way that we can put all the numbers together. 4 times 9 times 10. So we're using commutative property of multiplication to switch the numbers and the variables. We have all the numbers, 4 times 9 times 10, and closer, and 6 times 12 times 15. And for the variables, we go ahead and use what we learned before the first exam, the formulas, the exponent rules, to go ahead and multiply them. So for example, a times a, that gives us a squared here. And b times b third, that gives us 2b to the fourth. I did notice in the grading, there are some students who did not still are confused about the rules. A to the nth times a to the n, that's when you add these two exponents, m plus m. But if you have a to the m raised to another n, that's when you multiply them. I think some of the students were confused, still confused about these two formulas. Okay, the tip I gave in class was if these two powers, I do remember when we talk about the section and Ethan did answer, this is the power. And the tip is if you have two powers right next to each other, you should multiply them, not add. And I noticed in the grading of the exam, some students added them, which is incorrect. Okay, so now go back here, but in our case, it's b times b, so it's b times b third, and these two exponents, they're not power of power. They're not right, 1 to 3, they're not beside each other. So that's why we just add them, the formula. Okay, so we get 1 plus 3, that gives us a 4. All right. Now, in the denominator, we have a square, that gives you, there's another a. So 2 plus 2 plus 1, that gives us 4, a fifth. B squared, that's only 1. Okay, so you can go ahead and add them, multiply them, because it's not really too difficult to multiply variables. But for numbers, we don't really like to multiply them out. If you do, multiply them out, you're going to get a huge number. 4 times 9, 36, times 10, 360. And the bottom also, you're going to get a huge number, and try to reduce two huge numbers is more difficult. So that's why for numbers, we usually don't we will keep them as they are, and try to break down and see what you can cross out. So a quick way to do is if you see 4 and 12, 4 goes into 12 3 times, you can go ahead and do that. And then 6 and 9, okay, 3 goes into both of them, right? So you can go ahead and do this way. And then you see 10, 15, 5 goes into both of them. So you would get 2 and 3 like we did before, and then there's another 3 cancels 3, a 2 cancels 2. You can do this way because with numbers, you should be able to see what can go into both numbers. For example, 4 and 12, you can see 4 goes into both 4 and 12. But later with the variables, you're not going to be able to see that you have to break down. Okay, so you didn't have to follow this exact steps when you do that, but this is a different way. So what I did is I break down every number. Break down 4, 2 times 2. Break down 9, 3 times 3. Break down 10, 2 times 5. Same for the bottom. 6 is 2 times 3. 12 is 3 times 2 times 2. And 15 is 3 times 5. After I break down everything, I cross out the common factors. Maybe I can do it down here. So I cross out these two threes, these two twos, and these two threes, and these two twos, and these two fives. And you can see the top, every number is crossed out. In the bottom, there's a 3 left. So that 3 goes on the bottom. For the variables, like I said, variables are not like when you do multiplication, it's not you're not going to get anything big. So a times a just gives you a squared. B times b third just gives you b fourth. So you can go ahead and multiply them. But if you say, can I just go ahead and I see an a here and a down here, can I go ahead and cross them out? Yes, you can. Okay, you can do that way. Like I said, there are different ways to do it. And if you say, I see a b here and a b squared there, can I maybe reduce one of the b's? Yes, you can. But when you do that way, it's sort of messy. Okay, make sure you remember which ones crossed out, which ones are not. So a better way, a neater way is to go ahead and multiply all the variables. Okay, because they're not going to give you any huge numbers. After you multiply them out, multiply all the A's and the B's, A and the B's. You're not going to have A and the B everywhere, here and there, here and there. Okay, so when you cross them out, you're not going to miss anything. So when I see here 2 copies of A on the top, 5 copies on the bottom, if I cross them out, that just gives me 3 copies of A on the bottom. Okay. If you have trouble seeing this, because A squared means 2 A's, and A fifth means 5 A's. You have A. Trouble writing here. And when you cross out 2 of them, the top 2 will be crossed out. The bottom 5 of them will cross out 2 of them. That leaves you 3 of them. Okay, so that's why you have a third to the bottom. And similarly, 2 copies on the bottom and 4 copies on the top. You cross out the 2 of them from top. That leaves you another 2 left on the top. Okay, so that way it's not going to be everywhere. So if you didn't, I mean, you could technically cross A's out directly from the beginning and B's out from the beginning, but um, just when if you do that way, just make sure you don't miss anything, you don't cross out anything twice, okay? Because it's kind of hard to see when you cross out. As you can see, what I did here, it's like you probably even yourself when you look at it later, you're not going to realize you're not going to understand which ones you crossed out, which one you don't. But if you do factoring, it is much clearer. You can see these 2 cancel out, these 3, these 3, these 2. Okay. But again, it's correct. It's not wrong. I'm not saying it's wrong. This is correct. If you try to reduce directly, um, um, just be a little careful when you do that way. Okay. All right, so that's the first type of question in the homework. We didn't notice in this problem, we did not do any factoring. Why didn't we need to do factoring? Because everything is already a factor. 4 is a factor, A is a factor, 9 is a factor, A is a factor, B is a B cubed. So everything is already factor because there are only multiplications involved. So that's why we didn't have to do factoring. But the next example, as you can see, it's minus, minus here, and minus, plus, minus, plus, which means t squared is not a factor because of minus. It's a term. T fourth is not a factor. It's a term. You cannot cancel t squared and t fourth here because they are terms. We were able to cancel this b squared and b fourth because they are factors, because it's multiplication, see, multiplication everywhere. But in this case, both are terms. You're not going to be able to cancel them. Okay, so we have to use the same idea. We talked about it before. We have to factor the top, factor the bottom, factor the top, factor the bottom. the first step you will be you can do multiply straight across, which can this step can be omitted. Let me just write this way because I'm having trouble writing that way. Okay, so when you multiply the first step, multiply straight across. So there's a top t squared minus 3t minus 10 times the top, second top, 3t fourth plus 12t squared. And the bottom times bottom, t fourth minus 16 times 5t squared minus 26t plus 5. So you can write the step down and then factor each of them, each of these four. Or you can just go ahead and factor from the very beginning. So the first step is not very important. Okay, now, the other thing is, why do we have to do factoring here? Like I said, because, it's minus here, you won't be able to cancel t squared and t fourth. They are not factors. Secondly, the top does have two factors. See, because it's multiplication between the parentheses, that can be considered as factor of the top. That can be considered as a factor of the top. And the bottom has two factors, t fourth minus 16 and 5t squared minus 26t plus 5. But unfortunately, we don't find anything in common. See, there's nothing in common. Neither of them match. So that's why we have to continue to break down each one further. So maybe this is a trinomial. I may be able to factor this further. And this one, I may be able to factor out our GCF further. And this one, difference two squares, I may be able to factor this further and factor this trinomial further. After we factor each of them down further, we may be able to find something else in common, reduce them. Okay, so as you can see, when we multiply rational expressions, it's a lot of factoring we have to do. So in this case, we got to do 4 factoring problems here. 1, 2, 3, 4. Okay. All right. Any questions so far? Next, I'm going to see these factoring questions. We already learned how to do factorings. So I'm going to ask you to factor all of these out on your paper. And I'll give you, I will send like a pool here. I mean, like quick quiz, but it's not really a quiz. I mean, just like we did it before. And you can type your answer here. So go ahead, do factoring. I'm going to post the link in the chat box, and you can click on that link. Okay, let's see. Share. So you can go ahead and get started. I'm gonna post the link here. Okay, so click on that link and put your answer of factoring, the factoring answers under each question. Great. Oh, B. I try to use the second link. The first link is okay. Okay. The first two. Hold on. Somebody looks like delete the first two questions. Hold on. Let me put the back. Okay. So first one is t squared minus 3t minus 10. Second one is 3t fourth plus 12t squared. Okay, so you can refresh that page and you should be able to see all the questions and type in your answer. Okay, if anybody has trouble doing the factoring, let me know. I think if you have trouble doing any of the, there is a total of 13 factoring questions. So if you have trouble doing any of them, let me know. I can give you some hint. Colin, are you there?
Yeah.
Okay, because it looks like you signing as a guest. So I don't know if you are able to access this.
Yeah, I had to switch to my phone. I'm doing it on my phone.
Okay. You don't see a problem for number two. I just did the I think that should be there now. Hold on, let me. Can you refresh your browser? Refresh your browser, Abby. See if you can see the second one now. Because the first time I accidentally sent out the link that you were able to edit. So I think some students somehow deleted accidentally. So but I just put the problem back. You'll be able to see it now, Abby. Yes, that's right. Okay. All right. So I'm gonna actually give you some bonus points for doing this. So there's a total of 13 questions. I give you maybe a half point for each problem if you did right. That's gonna be a total of 6.5 points. I can see when after you submit, I should be able to see who I can see all your names and which ones you did right. Again, I can give you a hint to help you if you have trouble doing any of the questions. Oh, number 3. I'm sorry. Number 3 is also messed up. I need to put that number 3 back. Okay, let's see. It's t fourth minus 16. The 16 somehow got deleted. Oh, that was number 4. Hmm. I think somebody was still maybe using the old your old link, the first link. Can you try to use the new link that I posted? Because when you use the old link, you might accidentally delete my problems. So number 4, it's t fourth minus. Oh, I think one of the some students are changing my problems. Okay, you put your answer in my question. Okay, if you uh, if you see that you can change my question, please exit out, close that out, and try to use the new link that I sent out. Because you're putting your answer in my question. Because the first link I accidentally sent out is the link for you able to edit my problems. So please close that uh, link and try to open again from the chat box. All my questions are 5t squared minus 26. Okay. Somebody is still changing my questions. Okay. I'm gonna have to just make a different one. Okay, let me see if I'm able to disable it. Colin, can you mute your mic?
Sorry.
Fine. Okay, looks like somebody's still using the old link and changing all the problems. So here I'm gonna put the question up here so you will you know which question you're working on. So you will just type your answer for these. Okay. Well, maybe I should just go ahead and copy it. Just for your reference here, the first question should be t squared minus 3t minus 10. The second is t fourth minus 3t fourth plus 12t squared.
So do you want us to work these out on paper and email them to you then?
It's up to you. Either way works because the link is sort of is messed up. And so if you want on Blackboard, there's a place you can just upload under bonus 11. You can do that way. Okay. Under week 7. Or if you put the answer on that link, I will also be able to see your name. But it's just the you kind of have to follow the order. Don't look at the questions. Just look at my question here. Just type in and type your answer for each of them there. 1, 2, 3, 4. Just type your answer there. That way also works. T fourth minus t minus 16. Number 4 is 5t squared minus 26t. Plus 5. Plus 5. Plus 5. Okay. Next one will be 6x squared plus 7x minus 5. There are actually 12 questions, not 13. Somebody added a question there. 11.
So do you want us to keep using the link or just forget the link?
If you use the link, yes, you can. The number, use the new link on Blackboard to just type in your answer. If you want to attach your paper under Blackboard week 6, you can, week 7, sorry. Bonus 11, it's already posted there. So you can either also do that way.
Okay, so the new link's on Blackboard.
the forms that I sent out in chat, use the new one. Okay.
All right.
Or just go to Blackboard. To make it easier, you can just go to Blackboard. X squared plus 2. Okay, I just wrote down all the problems, 12 questions here. You can also use this, okay, because the original problems are messed up in the link. Okay, so I saw 2 submissions so far.
So on the link, we don't have to do 13, right?
Right. One of the question is shouldn't be there. Somebody added a new question there. I don't know which one now. It's just all messed up. So just look at my PowerPoint slide. These are the 12 questions you're supposed to do.
And can I still submit the link if I'm already done with the link?
Yeah, sure. Go ahead. I mean, then you don't have to, if you already have everything done, you don't have to submit to Blackboard. I'll just use this one.
All right.
Okay, so I have 3 submissions. So Jackson submitted, Garrett, and Aiden. And if you're done with these questions, you can, because I'm gonna give some other students a bit more time, maybe thinking 10 more minutes, and you can, if you want, you can use the 10 minutes to start, doing your homework problems, or you can just come back in 10 minutes. So we're gonna come back. We're gonna stop this process at guess maybe 1:40.
So I can use the link that you sent through like the messages.
Yes, you can. Just put your answer that way. That works. Hey, Colin, are you still there?
Yeah.
Did you intentionally miss the last one, or did you just forgot to do the last one?
No, I just intentionally missed it because you said don't do 13.
Actually, not number 12, you do have to do it. It's actually I think it was number 5. I just deleted it. It was an empty question. So there should be the problems you need to do is the ones you see on PowerPoint slide. I think it was the last one you missed. I do see all the other answers, but the last one. Can you also? I don't know. Can you also submit again the last one or not? From the
I
link.
can-
Okay. If not, you just submit the last one on Blackboard.
All right.
Okay. So Stephanie, I didn't see your message. Okay, extra number 11 and number 12. Okay. So Stephanie, for number 11 and number 12, first you will factor out the GCF. Okay, so like, did you do that, Stephanie? Factor out the GCF?
No, I forgot, but that explains it better. Thanks.
Okay. So after you factor out the GCF, you will be able to get like a difference two squares or trinomial. You continue to factor the difference two squares and the trinomial. Okay, if anybody else has trouble doing any of the problems, please let me know. So I'll give you 5 more minutes to finish these problems. And if you cannot finish these problems in class and you still want to do the bonus problems, and please send me an email and let me know, okay? Because I will have to give you different questions. So you can submit the ones you finish and to Blackboard or through that link. The ones you didn't have time to finish, or you can let me just send me an email. I'll give you I'll email you different ones you can work and still get points. Okay, so because I'm gonna give you after you finish, I'm gonna give you the solutions to all of these, and it's not gonna be fair to those students who already submitted. Okay, if you have not submitted, and then please go ahead and submit your work now. Just whatever you have, submit either to through that link or to Blackboard. Okay, so right now I have 8 students who submitted through the link, and okay. Okay, yeah, I see Abby, yours is submitting right now to Blackboard, and okay, so those students you have not submitted, please go ahead and submit right now. Okay, just whatever you have, and for the questions you were not able to finish, just send me an email to me, and I can send you similar questions that you can work on later. Okay, so right now I have Jackson's, Garrett, Aiden, Colin, and Raid, Natalie, Jake, and Ryan. And Abby's, let me see if it went through. Okay, Abby's went through. Stephanie, are you going to submit to Blackboard or to through that link? Oh, okay, I see 9 responses. Olivia also submitted. Okay, so looks like just Terry, I don't know. Terry, are you there? Are you still gonna submit your bonus? Bryson, and Stephanie. Okay. Please go ahead and submit yours. Doesn't matter how many you did, just go ahead and submit those. Otherwise, you have to do different types of questions. Okay, all right. Now, so I'm gonna go back to those questions. I went through your responses, your submissions. Most of you got them right, so which is good. I know some of you might have trouble with the factoring part. So again, please talk to me during office hours. And since it looks like most of you did those questions correctly, so I might go through these quickly here. Okay, so whenever you get a factoring question, the first thing we learned 4 types, 2 optional types. So the first thing you want to check is whether they have a GCF. You can do that very quickly. So like the first 10 questions, they don't have any GCF. So you can look at the numbers. You know, if you see 1, pretty much there's not going to be any GCF because the only number that can go into 1 is 1. And we don't really consider 1. I mean, 1 is called a GCF, but we won't factor out 1. But 11 and 12, you should go ahead and factor out the GCF, which in this case, 4 and 36 would be a 4. X and X cubed would be a X. So you factor out a 4X. And after you factor out, determine the GCF, you divide each of the terms by 4x. 4 divided by 4 is 1. X squared divided by x gives you x squared. And 36 divided by 4, it's 9. And x cancels x. And notice x squared minus 9 is still difference to 2 squares. So you can go ahead factor to get x plus 3 times x minus 3. So when you took the first exam, there's one problem that the last 5 factoring questions I usually gave you one step factoring to do, and you didn't really have to do 2 steps. Maybe there's one question I didn't pay attention that some of the students might have got that one, and you had to do 2 steps, but all of them you should just need to do 1 step. But today's factoring, like number 3, number 11, number 12, you need to do 2 steps. So first you factor out the GCF, and so that will be the answer for number 11, 4x times x plus 3 times x minus 3. Now in number 12, you can also factor out the GCF, which is 2, 4, 6, that's 2. And x third, x squared, x, you can factor out x and divide each of them by x. You're left with x squared minus 2x minus 8. And that is a trinomial, which can be factored further as x minus 4 times x plus 2. So you can see we did GCF and then trinomial. And in number 11, we did factor out a GCF, and then we factored this difference into squares. Number 3, first of all, it's difference to squares, because you can write it as t squared squared minus 4 squared. And that should give you t squared plus 4 times t squared minus 4. T squared plus 4 is not factorable because we don't have the sum of 2 squares type, so you keep it. But we do have a difference of 2 squares. So that t squared minus 4 can be factored further as t plus 2 times t minus 2. Because 2 times 2 is 4, gives you 4. Because 4 is actually 2 squared right here. Okay, so these are the only 3 questions that you have to do. Like right here, we have to do difference 2 squares 2 times. In 11 and 12, we had to do GCF first and then do difference 2 squares or trinomial. Okay. All right, so we're going to go back. I'm just going to put the answers. So with all of these factoring questions, so if you did all of them correctly, that's what I saw. Most of the students actually got all of them correct. If you missed any of them, and you can try to correct that. And let's go back to the beginning. So we're still on this question right here. Okay, so this one right here, which we just talked about. How to multiply rational expressions. So we are going to factor each of them. Write down the factoring. The first one, t squared, that was the one you did in the bonus, the first one, t squared minus 3t minus 10. You can factor it as t plus 2 times t minus 5. Or you can put a t minus 5 times t plus 2. Both are correct. The order doesn't matter. All right, and then the second top, this one, we got to factor it further. Apparently, that's different 2 squares. So we're going to factor out 3t squared, and that gives us t squared plus 4. Okay, after determine GCF, divide each of them by GCF. Now the bottom, that's the one I just did, number 3. I'm going to go ahead and just put the answer down here. T squared plus 4 times t plus 2 times t minus 2. I think it was number 3. And the last one is trinomial. So you should get 5t minus 1 times t minus 5. Okay, so that's the factoring. After we finish all the factoring, now we look for the common factors. That should be just one line here, sorry. Okay, so that, like I said, so it really doesn't matter if I kind of did that and just factor the top and the bottom, top and the bottom. And then you multiply straight across. Or you could just go ahead and multiply straight across and just put a line all the way through. It's all going to be multiplication. Okay, top times top, bottom times bottom. Okay, now we found we look for the common factors. The top, t plus 2, there's a t plus 2 in the denominator. T minus 5, there's t minus 5 there. And t squared plus 4, there's a t squared plus 4 here. And that's all. As you can see, when we originally, before we factored, we didn't see anything common. But after we factored each of them further, and we could have found more factors here. So now we are going to write down the top, which is 3t squared. The bottom, we have these 2 factors left, t minus 2 times 5t minus 1. And you can leave them as it is, okay? Because in this section, we are focusing on factoring and crossing out common factors. And the bottom, you don't have to multiply them out. We're not focusing on multiplication. So this can be left as it is, okay? 3t squared. Let me change the square here a little bit. Okay, so you get 3t squared in as the numerator and t minus 2 times 5t minus 1 is the denominator. Okay, so that was the first question. As you can see, the process here, multiply straight across following the first step, factor in the numerator and denominators, but we have more to factor in the numerator and denominator, because in the numerator we have another two factors in the denominator. We have to factor a total of 4 of them. And after you factor number 3, you just cross out the common factors because we have all multiplications everywhere now. So as you can see here, it's times between all the parentheses. If it's times, then you can cross them out. The last step, like you don't really have to multiply them. You can just copy the factors left. Okay, so for our homework assignment, you can just copy whatever left, top and the bottom. Okay, so that's the first example. So the let's go ahead and do this one right here. That's the one we just did, sorry. This one right here. And that top and the bottom, and the top and the bottom, these are the problems you did, number 9, number 10, number 11, number 12. So I'm going to just go ahead and put the answer up here. I think one of the students, I forgot if it's Garrett or somebody, I have to go back to look, missed one of the questions here, either number 10 or number 11. Okay, so we can look at the factoring a little quick here. We have 4 terms. Apparently, that's grouping. So the first 2, we factor out x. That gives us y plus 2c. The last 2, the second group, we can also factor out the 2, because the 2 is the only thing in common. And we still can get y plus 2c. And that's a common factor, which can be pulled out and put it in the front. And then after we pull out these 2 factors, we're left with x plus 2. So that first one, we should have y plus 2c right here. That top can be factored as y plus 2c times x plus 2. X plus 2. And the bottom, we will have, I think it was x, factor out of x, you will get, similarly, you do exactly the same thing, these 2 and these 2. So if you factor out of x, you will get y minus 3c. And the other one, you factor out of 3, you get, so you will have x plus 3 there. Okay, so I skipped that step. You should be able to follow the top to do the bottom the same way. And multiply, you factor out that, which is the number 11 we did. I'm going ahead and copy the answer here. 4x times x plus 2 and x minus 2. And the bottom is the last one we did, which was 2x times x minus 4 and x plus 2. Plus 2 and x minus 4. All right, so after we're done with the factoring, now we look for the common factors to cross out. Because notice it's multiplication here, and it's multiplication here, multiply straight across. Times. So we can find all the common factors to cross out. Notice that there's x plus 2, and, oh, did I miss? Sorry. I think I missed a little. Did I miss anything here? X, let me check. So that's x minus 4 times x plus 2. Minus. Okay. Looks like that's the only 2 that can be factored. I actually meant to have two more. Did I miss anything? Am I? Okay, so these two x's can be crossed out. And this 2 and 4 can be crossed out. Reduce 2 and 4, because 4 and 2, they're also factors. Anything else? Looks like that's it. So we can copy down the final answer. I may have, I actually meant to ask you to cross out something else here, but looks like I may have messed up something. So we end up with 3 in the denominator. In your homework, you should end up with only 2 of them. The top, we have this one. There's a 2 there. I'm going to move 2 up front. X plus 2 and x minus 2. Oh, did I think I copied it wrong. Sorry. Plus 3 minus 3. Sorry, that's why. Okay, sorry. So that should be here a plus 3 here, minus 3 here. That's why we can cross out these 2 here. Okay, so I just copied them wrong here. So let me get rid of this should not be there. And that should not be there. Okay. So we should be left with the x minus 3 on the top and x minus 4. Okay, so when you do the homework, you should end up with something very similar like this. You should be able to cancel out two factors. Okay, so that's how we do this one. Now there's one more left, which is division. Okay, so the division, dividing these two, is sort of like dividing fractions. And we first use keep, change, flip. So we'll do keep, change, flip. The same rule we applied before when we divide fractions. So we keep the top, keep the bottom. So the first fraction will be kept. The first fraction, and then we change division to multiplication, and we flip the second fraction. We call it a rational expression, but if you want to call it a fraction, that's not a big problem. Okay, so dividing fractions is equivalent to multiply its reciprocal of the second one. So after you change division to multiplication, then you factor each of them there. Okay, so that's something you just did in your bonus, like 4, 5, 6, 7. So you can go and copy your answers back here. I think I can look at your answers. So that all of these are trinomials. The number 5, the answer should be 3x plus 5 times 2x minus 1. Looks like Olivia, you made a mistake in this one, in this question. Everybody else looks like you got right, who submitted. Okay, so it's 3x plus 5 times 2x minus 1. 3x plus 5 times 2x minus 1 to break down that one. Okay, so notice how do you know whether you did it right or not? After you factor, you can quickly check the multiplication. 5 times -1 will give you -5, right? If you don't get -5, that means that cannot be right. And similarly, you do FOIL, 3x times 2x should give you 6x squared, and also negative 3x plus 10x gives us 7x. So that tells us this factoring is correct. If you cannot go back to the trinomial given, that means you did something wrong. Okay, so the bottom we can factor it as x minus 6 times x plus 4. And the other trinomial, this trinomial can be factored as, let me take a look, see if anybody missed that one. Okay, so that should be 4x minus 3 times x plus 6. Okay. Looks like, yeah, we got 2 students missed that one a little bit. So it's 4x minus 3 times x plus 6. Okay, and the last one, let me check again. So the last one, it's 4x minus 3 times 3x plus 5. Again, we have 2 students who missed that one. Okay, 3x plus 5, 4x minus 3, and 3. Maybe you try to redo those. The trinomial one, what you can do, there are different ways you can do it. The way you learned before, if you can give you the correct answer, you can stick to the way you did it before. Otherwise, if you can get the right answer, you might want to do the box method. So you break down 12 as 4 times 3. You break down x squared as x times x. And you break down negative as negative 3 times positive 5. Because negative 3 times positive 5 is negative 15. 3 times 4 is 12. X times x is x squared. And when you do cross multiplies, you want to make sure, so negative 9x plus 20x, that can give you the term in the middle, 11x. Okay, after we break down everything, now look for the common factors. 3x plus 5, 4x minus 3. Oh, I'm sorry, I missed it here. Okay, so that should be a plus here and a minus here. Okay, so again, if I had a minus and a plus, I would end up with -2, not a positive. Sorry, I missed that one there. And now x plus 6 cancels x plus 6. And now we copy down whatever left, 2x minus 1 over x minus 4. And don't cancel this x and that x because these are not factors. There's a minus behind it. So that would be your final answer. Okay, so I gave you one example for each homework problem this week under section 4.2. So you should be able to follow these, and technically you just have to do factoring on each one and find the common factors to cross out. Okay, but be careful with the factoring. So sometimes you may make mistakes, like the mistake I just made. When I get here, I found x plus 6 and x minus 6. They are pretty close. And it could be, they could have done this intentionally to trick you, but most of the time, I think the problems were made to let you cancel out as many factors as possible. So maybe you can double check, see if you made a mistake like I did. It should be a plus 6, then they can be canceled. So usually the problems gave you, they're trying to give you as many factors, common factors as they have, so you can cross them out. Okay, so that's the section 4.2. And as you can see, it's not really anything new. How to divide fractions, keep, change, flip. We learned that before. And how to multiply fractions straight across. We also learned that before. The only thing, the process is still not new. Like you have to cross out the common factor. But how do you get common factors? It's not, this is something different from numbers because you cannot see what goes in each of them without doing factoring. But the factoring part is not new either. So we practiced a lot before the first exam. After you factor all of them, you found out common factors and cross them out. Okay, so technically, nothing is new. We learned factoring, we learned to keep, change, flip, multiplying straight across, and we learned how to cross out common factors. But it's just it's a new type of problem. But we were able to use the methods we learned before, or the steps we learned before, to solve this new problem. Okay, any questions? Okay. All right. Now, next we already did the bonus, and I'm not going to ask you to do any new bonus today. So we have about 15 minutes. I'm going to start the process of fractions, adding or subtracting fractions. Okay. And we, again, start with how we add fractions, which we reviewed during the first week. The steps first, we have to have the matching denominator. So in order to do that, we need to find the least common denominator for 4 and 6. So we can, because we can see it's 12. If you don't remember how to find the least common denominator, there are two ways. One is to list all the multiples of 4 and 6, find a common one. The other way, which will also be used today for the variables. So the other way I reviewed during the first week was to break down both numbers, factor both numbers, 4 as 2 times 2, 6 as 2 times 3. We create a new column for a new factor, a different factor, line up the same factors. I guess technically we're supposed to line up the first two, but it doesn't matter here in this case. So the LCM is bringing down one number from each column, so that gives you 12. This method will be used again when we have variables. Okay, all right. But for numbers, you might not need to do this. You can see it's 12. So after you get the least common denominator, you just have to equal the denominators to get change both of them to 12. So for the first one, we will multiply by 3 and 3. So that gives us 9 over 12. The second fraction, we multiply by 2 and 2. That gives us 2 over 12. And after we get the matching denominator, we keep the common denominator 12. Add the numerators, 9 plus 2, 11. Okay, so that's what we did before. We reviewed it during the first week. Now, what if we have variables in there? Well, we follow exactly the same 3 steps. First, find the least common denominator. We have 4, 3, and 6, which is still 12. You can see 4 goes into 12, 3 goes into 12, 6 goes into 12. And next, we're going to equal the denominator. So in the first case, we need to change 4 to 12. We can multiply. Let me slow down here. Okay, so that's the first fraction or rational expression. In order to get 12 in the denominator, we can multiply the bottom and top by 3. But what you need to be careful is this 3 is supposed to multiply the entire top. With numbers, your top is only going to be one number. They're not going to give you 2 numbers like 3 plus 7 on the top. They won't do that. It's just going to be a single number, right? So you never need to worry about distribution. Just 3 times 3 gives you 9. But now we have 2 terms, x plus 2. So when you multiply the top by 3, you will have to distribute the 3 to both of them. So that means you actually have to put parentheses there. I mean, technically, it's not correct if you don't put parentheses. If you don't put a parenthesis, it only means 3 times 2. You don't need to multiply 3 with x. I saw a lot of students who just who didn't put parentheses, but still distribute 3 to both of them. Technically, the writing is not correct. You're supposed to put parentheses there. So to put the top in the parentheses, consider the top as one whole thing, not 2 separate things. So we need to multiply both of them by 3. Okay, so I'm going to do the same thing with the second one, x minus 1 over 3. Okay, I'm going to put that x minus 1 in the parentheses because I'm going to multiply by 4, both top and bottom by 4, because the top has 2 of them. Now minus the third one, which has x minus 4 over 6 and times by 2. Okay, so this process is the same as we did it, but make sure you put parentheses for each factor. Sorry, not factor, each numerator. Now we can get a common denominator. 3 times 4 is 12. 4 times 3 is 12. 6 times 2 is 12. So we get a common denominator 12. And the numerators, I'm going to slow down. You can skip the step later, but be very careful. You might, if you skip this step, you might make a mistake in the distribution part, subtraction part. So what I did is I just copied the top plus top minus top. I went ahead and moved the number in front of expressions. It's just easier to distribute from the front to the back instead of back to the front, but it's the same thing. So the next thing we're going to do is distribution. 3 times x, 3x plus 6 plus 4, distribute 4. The tricky part is the last one. the last part, we're supposed to distribute -2, not just 2. So you end up with -2 times x. And then -2 times -4, that gives you +8. Okay. The mistake is right here, +8. Some students will have -8 there because they were thinking, well, we're distributing 2. If we distribute 2, that just gives me 2x minus 4, minus 8. Why do we have +8? Okay, if you distribute, if you skipped this step and you're thinking you're distributing 2 to both of them, you end up with 2x minus 8 instead of +8. That's because you haven't done subtraction yet. This minus sign also needs to, so you're doing minus 2x minus 8. And as the top, 2x in the parentheses. So that gives you -2x, and negative times -8 still gives you positive. So if you didn't write this step, a possible mistake is you might be thinking it's -2x minus 8, forgetting distributing this minus sign. So it's a very common mistake there. Okay, so this minus sign, remember, it has to be, you are subtracting the whole top. So you're subtracting 2x and then subtracting 8. So it's -8, which becomes +8. And after that, we just combine like terms in the denominator. So you will have, you will have 12 and 3x plus 4x minus 2x, 7 minus 2 is 5x, 6 minus 2 is 2 plus 8, it's 10. So the answer should be 5x plus 10 over 12. Okay. All right, now let's look at, so this is similar to the first homework problem in homework 1, for homework problem in section 4.3. Now, next one, these two. Okay, the top, look, the top doesn't just has a single number now, or a single variable term, like it's called a monomial, 7a. So it doesn't have to have plus or minus. But in the denominator, as you can see, we have a bunch of variables like n squared or 3n, or 12a squared b, 3b squared. So when we try to do the first step, find the least common denominator. Where previously in both examples, even if we have variables in the numerators, the denominators are all numbers. So we didn't have any trouble looking for the LCD. 4, 3, 6 is 12, right? But now, when you have variables, how do we find the LCD? Okay, first I'm going to do it the same way as we did with numbers. How do you find LCD? If you cannot see it, break down, factor each number, and bring down one number from each column. Okay, so we can do exactly the same thing here. So I can, so when I look for LCD, put it down here, I take the first denominator n squared and break down, factor it as n times n. The second 3 can factor it as n times 3. So I line up the same letter, and if there's nothing the same, I create a new column. And the last one is 2. It's a number. 2 cannot be factored further. Just create a new column for that. So now I'm going to bring down the least common multiple. N first column, n second column, 3 third column, and 2 fourth column. And we multiply all of them. That gives you 6n squared as your least common denominator. So the method to look for the LCM, here we call it LCD. D means denominator, but it's the same as LCM. So the way to look for the LCD is exactly the same as we did before. Factoring, bring down one from each column, and multiply them. So you may have variables. So similarly, I could do the second one the same way. How do I find the LCD? So let me write down the LCD here, 6n squared. I'm going to do the rest of it in a second. So let's break down 12a squared b. And that's going to be 12 is 2 times 2 times 3. A squared is a times a, and b is just a b. Now 3b squared can be factored as Okay, there's a 3, and then b times b. Okay, now we bring down one number or the variable from each column. So 2, 2, 3, a, b, b. Now multiply them. 2 times 2 times 3, it's 12. A times a squared. B times b squared. So we find the LCD is 12a squared b squared. Okay. All right, but this process, as you can see, it's tedious, right? And I'm going to give you a tip, a quick way to look for the LCD. You don't have to break them down all the way. So first of all, you look at the numbers. For example, in the first case, you got LCD 6. Where does 6 come from? It's just the least common multiple of 2 and 3. So when you look for the LCD of all three of them, you first look at the numbers. So I have 3 and 2. What is the least common multiple of 3 and 2? That's 6, right? So we already did it during the first week. So hopefully you can just see it without breaking down. And for the variables, and look, we have n squared and have n. Which one did we? We take the one with the higher exponent. Okay, previously when we did a GCF, when you look for GCF, during the first week I gave you a tip to help you to compare to distinguish between GCF and LCM. I don't know if you still remember. You can go back to watch the first recorded video under week 1. So the biggest difference between LCM and GCF, F means a factor. Usually the factor is smaller, but M means multiple. Usually when you multiply a number by another number, multiple is going to be bigger, right? So that's a quick way to help you determine whether you got it right or to distinguish between them. So usually when you look for GCF, you pick the one with the lower, say 436, you pick 4. 4 goes into both of them. X and X third, you pick the lower one, pick X. You don't pick X third because X third does not go into X, but X does go into X third. So when you look for GCF, you pick the one with the lower or lowest exponent. So when you have 3, you pick the lowest, which is X. Well, here we're not talking about GCF anymore. We're talking about LCD, which is LCM. So when we look for LCM, this M means multiple. So you're going to take the bigger one. Okay, so n squared and n, you're going to take the one with bigger exponent. So if you remember this, you don't have to do all the factoring. So when I look at the question, I just quickly check. Okay, what is what is the least common denominator multiple of 2 and 3, which is 6. N squared and n, which one has a higher exponent at n squared? So that will just give you the LCD immediately without doing all of this. But the idea comes from here because these common multiple has to contain all of them. Everything you have to have it. So n squared is a multiple of m, but not the other way. And you cannot call n a multiple of n squared, right? So multiple is always bigger. Okay, similarly, when I look for the LCD of the second question, I don't have to do all of this. I just look at 12 and 3. The LCD is 12 because 12 goes into 12, 3 goes into 12. When I look at the variable a squared, well, in the other one doesn't even have a, which means a to the 0, because if you don't have a, means 0 copy of a, right? So of course, a squared is bigger than a to the 0. If you want to contain it, you must have it. Okay, so you have to pick a squared. And then when you look at the b and the b squared has the larger exponent, so you have to use b squared. Okay, so the tip is for the variables, you pick the one with the larger exponent, and that will give you LCD. Okay, so after you found LCD, the rest of the process is going to be exactly the same as we did before, equal the denominator. So I'm going to go ahead and clean that up. So we're going to change all the denominator to 6n squared. How do you change this to 6n squared? I already have n squared, so all you have to do is to multiply both top and the bottom by 6. And look, bottom 6n squared, and top, whatever that is, 30. Now the second fraction, I can multiply by 2n, because in the first fraction, I didn't have to multiply any variable because I already have n squared. But the second case, I have to multiply by 2n because n times n will give me n squared, and 3 times 2 will give me a 6 needed. And the top will be 4n. And the last one, I just need to multiply by 6, and I'm sorry, 3n squared. Okay. So that gives me 3n squared on the top and 6n squared on the bottom. And after we match the denominators, I keep this common denominator 6n squared and add or subtract the numerators. All you have to do is to copy all of them. And notice that the top cannot be simplified any further. And this will just be the final answer. Okay. All right. I think I'm going to do the second one on Thursday, and we can stop here for today. I started doing addition, and I will give you more examples on Thursday, and this example and a few more. Okay. All right. So that's all for today, and make sure you type in present for today's class. And have a good day.
Hey, Dr. Shao, I have a question on one of the problems on homework 6. Never mind.
Ha, good one.
That was cold, dude.
Hey.